Welcome, everyone, to Managing Linear Assets Using Location Referencing and Schematics. My name is Jim Barry, and I'm a solution engineer with the transportation team here at Esri. I'm joined here today with my colleagues Koye Brown and Eric Rodenberg, and over the next 45 minutes, we're going to share with you information we believe you'll find useful, showing you a variety of creative ways to use location referencing tools within ArcGIS for managing your linear assets. In addition to describing these techniques and best practices, we have a few demos for you to show you these tools in action in a way that you can put to use right away. As you know, or might imagine, linear data is an important part of transportation infrastructure management. Whether we're moving vehicles along roads and highways, or trains along rail lines, ships across the seas, or aircraft through the skies, managing that movement data, both in real time and also analyzing patterns over time, techniques for managing your assets and vehicles requires a lot of linear data. First, Eric Rodenberg is going to cover location referencing as the primary way that we keep track of location. While it's true that over the past few decades, vehicles of all types more and more make use of GPS for global location using spherical coordinates, and sometimes projected into local coordinate systems. In the transportation industry, it's very common for locations to be described as measures along defined routes, not only for tracking the location of those vehicles, but also from an infrastructure management perspective, for locating the position of assets and equipment that are part of your infrastructure. For example, rail line wayside equipment like signals, switches, grade crossing safety arms, and so on, located not only by their lat long, but also by their measure along routes that make up the network. Eric is going to show you how Esri's roads and highways technology can be used, not only for roads and highways, but also for rail and other kinds of transportation. And he also has a live demonstration for how tools like the event editor and ArcGIS dashboards can be used for managing and visualizing your data. Next, Koye Brown is going to discuss how the ArcGIS utility network can be used for transportation. You might be familiar with this tool set. The utility network is a very popular way for industries such as electric, gas, water, wastewater, and telecom. But we've been doing a lot of work lately on how we can use this tool set to help manage transportation assets and operations, in particular railroad assets and operations. There are a lot of parallels between, say, a water utility delivery system and a rail network. There are places where the movement begins and ends, then a network through which these things move, and where there might be a valve for opening and closing and redirecting the flow of water. Railroads have signals and switches and turntables and even derailleurs for controlling the flow of trains, both for getting them to where they need to go and also for managing flow on the network to facilitate planned and unplanned maintenance operations. Koye will then show a demo for how railroads can use the utility network. In fact, let's call it the rail network, for doing operations that it does well, like tracing operations and controlling the flow of trains using switches. And given the railroad industry very often maps their operations using schematic maps, in addition to geographic maps, Koye will show you how schematic diagrams of railroad networks can be generated and updated automatically and exported in a way that linear referencing schemes can then be applied. Finally, I'll be back to discuss schematic maps in more detail and how ArcGIS can be used to take those schematic diagrams that Koye created and do two things with them. First, the schematic diagram can be used to support the creation and update of track charts. And second, I'm going to show a live demo for how a web application can be built, which combines a geographic view, a schematic view, and also straight line diagram views of a railroad network in a way that allows them to be used synchronized. And for these three interactive views to work, it all starts with building a good linear referencing system to help build that digital twin that all of your map views can synchronize to. And for that, I'd like to introduce Eric Rodenberg, a solution engineer with our transportation team, who's here and he'll go through that with you. Eric?
Thank you, Jim. For the next 10 minutes, I'm going to be discussing ArcGIS location referencing. Specifically, I'm going to talk about roads and highways and pipeline referencing. Roads and highways and pipeline referencing are the solutions that are bundled under the ArcGIS location referencing product. Depending on the industry you work in, you might use one over the other. However, they are virtually identical. The pipeline referencing solution does have some data model specific components that are tied to oil and gas, but if you're in rail networks, transit, roads, primarily you're going to be using roads and highways to model your location referencing networks. Let's go ahead and take a look at some of the slides. Specifically, what this slide is really saying is that ArcGIS location referencing is supported across the entire platform. Pro is where we're going to be doing a lot of work to manage our LRS network and center lines. Specifically, we're going to do our route creation and loading, our event loading. We're also going to be, we also have access to geoprocessing tools to help facilitate that work. And then we have tools like Data Reviewer to support QA/QC checks against the data as we make edits to it. And Workflow Manager allows us to create specific workflows that follow standard operating procedures. So if I need to create a specific workflow for my editors to create a route or retire a route, I can use the Workflow Manager to basically step out that process and then deliver a tool that follows that process for the editors. All this data that gets created in Pro is made accessible to the rest of the enterprise through location referencing web services. And of course, those web services are exposed through the REST API. And we have loads of developer API samples that developers can use to build custom web applications. Speaking of web applications, location referencing ships with the event editor. The event editor supports line and point event editing, data queries, quality checks, and then we also have Roadway Reporter, which allows us to build specific reports against our data, so mileage reports, those types of things. And then we can also do address management as well. Looking at the fundamentals of an LRS is primarily consists of a route which contains a route ID and measures. And then from that, we can locate events on top of it. The events are our assets or our business logic with assets along that route. So for instance, if I manage speed limit, you can see here on this map that from 0 to 0.22 miles, the speed limit is 25 miles an hour, but at 0.22 miles, it shifts over to 35 miles an hour all the way out through the end of the route. We also have address ranges. So from 0 to 0.16 at the intersection of Pine Avenue, the address range for Elm Street is 0 to 99. And then at Pine Avenue, it shifts to 100 to 199. And at A Avenue, it shifts again to 200 to 299. So using the route ID and the measure, we can break up where those changes occur. We can also locate events based on a reference offset. So if I wanted to know from the from an intersection offset, so if I were to go 382 west of A Avenue, I would find a pothole repair. And if I went 141 feet east of A Avenue, I would also find another pothole repair. So that's a intersection offset. And then finally, we can do what's known as a geometry to measure, where we're taking a latitude and longitude and converting it to a measure. Essentially, a fatal crash report or a crash report that's logged by a police officer, they're going to generally log a lat long, but we'll take that lat long and turn it into a mile point on a route. In rail networks, it's the same thing. If I wanted to model speed, if I wanted to model curvature, grade, I would model those as line events like the speed limit and address ranges here. If I wanted to model things like crossings or switches, I might model those as points like the pothole repairs and the crash. So those are some of the basics of the LRS. Now let's talk a little bit about let's talk a little bit about location referencing with regard to the architecture. Location referencing is hosted by ArcGIS Enterprise. This is an important component. You have to have ArcGIS Enterprise and specifically Windows. And the extension comes for ArcGIS Server and ArcGIS Pro, the desktop. So the Pro is where we model and maintain all the geometry, and then the server, which is federated to our portal, allows us to manage all the events. And then the portal acts as the gatekeeper. It essentially controls the named users and access control to the hosted feature service that we're going to be accessing through the event editor and through Pro. All right, with that, let's shift over to a demo. So first of all, let's start with the operations dashboard. And you can see in this dashboard, I have some lane events. These lane events represent various roads in Oregon. We're looking at I-5 in Oregon. Specifically, we're looking at, you see here McDowell Road, it just kind of ends abruptly. And the reason it ends is the exit ramp has recently been extended to accommodate some tractor-trailer traffic, or the tractor-trailer traffic that was backing up onto I-5. It was backing up so significantly that the right lane was being blocked by the trucks trying to get off the road to get to the lumber mill. So the DOT extended the ramp so that the trucks could safely get off the road and the through traffic could pass through without incident. So I want to go ahead and I want to update the events so that they are reflected in this dashboard, and then the lane mileage should update from 29.05 to the new lane mileage once we do our edit. So let's go ahead and let's jump into the event editor. So again, we're looking at that that exit ramp at I-5, and you can see the route is here. It's been connected in. Now we just need to update our event. So I'm going to go over to the edit tab, and I'm going to edit this line event, and I'll start by selecting the route. And so when I select the route, you can see there it highlights it and fills in the route ID in my dialog. And now I just need to locate my start and end measures. And when I specify here in the dialog the start and end, it automatically populates crosshairs at the start and end of the route. Now, if I wanted to, I could override this with my own measure. So if I know a measure, I can type it in, and the green crosshair updates from 0 to 0.15 along the route where I typed in. I can also, as I mentioned earlier, that I have access to geometry to measure. So if I choose select the location on map, this is essentially making that geometry to measure call. I'm clicking on the map, we're turning an XY coordinate into a measure, and then reflecting that measure in the dialog. In addition, I can also locate items based on an offset. So I could do a milepost offset or a bridge or culvert offset, or I could offset from a station and offset. So if I had station values, I could plug those in, or I can just plug in coordinates as well. In addition, roads and highways is temporal. It manages time, specifically start dates and end dates. So when we retire something, we'll populate an end date. Now, we're creating new events today, and actually we're going to backdate this 2 days. So let's go ahead and do that. And now I'm going to go ahead and just update my event values. And as you can see here, this supports drop downs, domains. Now I'm kind of lazy. I don't like typing all this stuff in. So I'm going to use my copy attributes tool, and I'm just going to click on McDowell Road, and we're going to grab all the attributes from McDowell Road. So it's a little shortcut. It's a time saver. And I'm just going to update my lane miles to 4. And these checkboxes that you see in the dialog, they represent layers. So each one of these checkboxes represents a layer. So I'm going to be, in fact, updating 6 layers at once. So let's go ahead and let's save our edit. And you can see here, all these events just updated. So we now have a lane event. So now let's go back to our lane event dashboard, our lane inventory dashboard. And you can see now my lane event sitting out here, and my measures jump from 29.05 to 30.25. That's because we put in 4 lanes at 0.3 miles. And so the Roads and Highways was able to calculate a lane mileage automatically for me of 1.2 miles. And then it also did a line and polygon analysis to figure out that this is in region 2. So this is just a little high-level overview of how roads and highways works. With that, I'm going to pass things over to Jim Barry, and Jim is going to take you through utility networks for transportation. Jim, take it away.
Thanks, Eric. Now that we've seen how LRS can be used in transportation, let's pivot to another robust, industry-proven toolset in the ArcGIS platform and how it can support transportation mapping. And that's the ArcGIS Utility Network. First, what is it? Well, it's a component of ArcGIS that provides tools for working with a variety of different kinds of networks. And as its name implies, the most popular uses are with various utilities and the assets that they manage and operations they perform, such as electric, gas, water, wastewater, and telecom. For them, it's not enough to manage and visualize their assets on a map. Utility Network provides the ability to design rules and behavior that individual asset types have. For example, there are rules about what kinds of electric distribution lines can connect and not connect with other types of equipment, or how many transformers are allowed to connect to a pole, and so on. You can also trace the impact of damage to the system. For example, which houses will have their water cut off if a water main is damaged in a certain spot. While its use in transportation has been limited so far, we do see value in the way that it works for transportation, since it's also a domain where digitizing the world into points, lines, and polygons just isn't enough. You want to design rules into the objects also, so that you could better manage the overall system. Here's a nice image showing how the real world is modeled into a digital twin. And by twin, not just in the way that the system appears, but also how it works. As you can see below, this natural gas network is designed with many different types of equipment, each with its own behavior. We're already starting to see usefulness with railroad networks, not only to trace the flow of trains and seeing how different parts of the system are connected when switches are activated, but it can also be helpful when running an isolation trace in order to decide which switches need to be activated in order to flag out a section of track in order to perform maintenance safely. Another advantage of utility networks with transportation uses is that some networks, like railroads, for example, are associated with other kinds of networks as well. For example, in the graphic here on the top left, what you're actually seeing is a rail line and an electric line, and they're associated side by side. Quite a number of railroads are electric powered, for example, using overhead catenaries or third rails. And wayside equipment like signals and crossing arms need power also. So the utility network gives you a way to map and design and model these associations between these networks, managing flow, supporting maintenance, and so forth. Here in the upper right, you can also see that in addition to working with your maps geographically, utility network recognizes that a schematic view can sometimes be the best way to visualize the system. Within Utility Network are tools for automatically generating and interactively editing schematic diagrams. So whether you want the schematic diagram to be live and interactive, or to support your update and publishing of track charts, these tools come in handy. New at ArcGIS Pro 2.6 are a set of trace network tools. You can think of it as sort of a utility network light. It provides some basic flow and tracing tools built right into the core software of ArcGIS Pro. Here, you see some symbology for examining flow and also tracing along a railroad network. And trace network tools can also generate schematic diagrams. Track charts are an important part of what a railroad needs to operate, and an important part of what you can do with GIS and mapping. Now, what we're not looking to do is that we're not looking to create, say, a track chart generator extension, because A, that's a few steps ahead of where we are at the moment, but B, we all know that most railroads have their own ways of creating charts, their own symbols, their own standards, their own ways of wanting it to look. What we at Esri would rather do is provide better enabling technology to continue to make ArcGIS work better and provide more tools for you to create your own charts, better and easier than you are now, and in a way that sources that content from the same single source of data that's driving your other derivative products. That way, you edit once and all of your maps and tools see those changes. Not only to provide better tools for keeping your charts updated, but using the power of WebGIS to make track chart use less static and more interactive where that's more useful. We want to continue learning from you about how you create track charts, how you maintain them, and how you use them across your organization. In a little bit here, I have a demo for this kind of idea that uses LRS, and it's a little bit further evolved, and I'll show you that in a moment. But first, what I'd like to do is introduce Koye Brown. She's a solution engineer on our transportation team and an expert with the utility network for transportation. She's going to start with the elements of how transportation maps, and in this case, railroad maps, can take advantage of the capabilities provided by the ArcGIS utility network. Koye?
All right, thanks, Jim. Hi, I'm Koye. I'm a solution engineer supporting the utility network for transportation. And today we're going to take a quick look under the hood of the utility network with LRS for transportation. So let's get started. I'm going to hop over to my areas. I'm going to select some rail lines, and then I'm going to create a diagram. It's just that simple. It's in the toolbar. It'll go ahead and generate a schematic. When you first generate a schematic, it's going to look just like your geographic. So on the left side here, we have our geographic, the features we selected. On the right, we have the diagram. Now I'm going to apply a layout to that diagram. I'm not going to make any modifications. I'm just going to run. Then I'm going to see that diagram change to the mainline tree diagram. So I see this dot out here, or this switch, and then I want to see where it's located and what it's connected to. It's starting to look like possibly the switch is a little off on the line breaks, so it's disconnected from those lines. So an important part of the utility network is the network connectivity. So it does have topology, and you can generate topology errors. This isn't generating an error, but it seems to be a bit off. So we may need to go back and edit that. I can select features in the geographic space and apply them to the schematic. I'm going to clear out these. Now I'm going to store the diagrams. So we can save all of these diagrams so that we can retrieve them later. I'm just going to name it. All right, and click run, and then it's stored. We'll go back and find those. So once you store them, you can go and you can export these. So the typical workflow is you would export the diagram content, and it will export a JSON. You can export a GeoJSON as well. Or you can just do a feature-to-feature export and write those to your output location like I'm doing here. So I'm going to go ahead and extract the rail devices, which are the switches, and then the rail main line, which happens to be the center line of my LRS. All right. Now I can see that those features have been exported and they're on top of my schematic features. Let's explore. Let's see what we got here. All right. I can see my diagram rail features that I exported a direct copy to copy. Now I want to go ahead and create an LRS. So I'm going to create a schematic LRS. Just going to populate the geoprocessing tool here. All right, I've generated an LRS. Now I'm going to go and check that. To do that, I'm just going to right click, go to properties, and then check the LRS and see that it's been registered. Now I'm going to create an LRS network. And the important feature here is that the measure units are the same as your geographic unit. So we didn't go through this, but I have an LRS with my utility network that's in miles. And so when I generate this schematic LRS network, I want those units to be in miles as well. The benefit of that is because we want to be able to crosswalk between the two LRS networks so that we can go from geographic to schematic. We can edit events and then see those overlaid in both the geographic space as well as the schematic space. Jim, I think I'm all done. So back to you.
Thanks, Koye, for showing how that works. Combining the power of both linear measurability of an LRS and the object behavior and flow tracing in a rail network using utility networks. While Koye's example was quite interactive, the schematic she generated can also be used as a component of the building and maintaining of track charts. As we've been working with railroads, one of the consistent things we've often found is organizations dealing with multiple sources of data, and it can be difficult to keep them in sync. When data in an enterprise asset management system and in your GIS and on your printed track charts are maintained separately, are you ever really sure which one is the most correct and most up to date? Like the slide shows here, the geographic data and schematic data are linked, so that edits in one update the other. This naturally leads us to talk about architectural considerations that a lot of these new capabilities are designed for. Many existing systems that we've seen have multiple databases throughout several teams and departments within an organization, probably not unlike what you see here on the left. In that scenario, GIS isn't necessarily seen as the central place or even an enterprise integrated place where this data can work along with your other enterprise systems. As such, there are redundant copies of data from different sources at different levels of accuracy, storing department-specific data, sometimes maintained manually, sometimes maintained by contracting out over spans of time to third parties. This decreases both the timely usefulness as well as not being confident that everyone is working off of the same data. In contrast, let's take a look at the different architecture pattern here on the right and its implied advantages. At the bottom, while we still have multiple sources of data from multiple departments that they create and maintain for their own purposes, and they still retain full ownership and control over these data sets, they all feed into an organizational tier here in the middle that we call a portal. The portal is where all of this content is organized and indexed, searchable and findable, and published up as web services. It's very important to point out that this design does not imply the merger of everyone's data into a single database and a free-for-all access. No. Everyone still controls their data for their purposes, but the portal layer is there so that others can benefit from your data and you can benefit from theirs in a controlled way, which minimizes data redundancy. At the portal tier, you can also create and manage groups, users, and roles in order to provide this access, but still in a very controlled way. Perhaps you want to share a layer, but you want to hide certain columns. Perhaps you want groups other than your own to have access to the data, but only in a read-only way, so that they cannot edit it. This ability to organize content, tools, and users throughout your organization is provided by the portal. Or it can inherit user authentication from your enterprise, like Active Directory, for example, or some other LDAP-compliant directory server. And at the top of the chart here are web clients, from heavy PC workstation software to native mobile apps and web browsers. Everyone is using REST endpoints to read these web services, and no one needs direct database connections, which improves system security. And the client users don't need to keep track of updates and changes. When you update the data on the back end, your users just see the changes as they view and work with the maps and work with the tools. So as you can see, GIS is more than just a place to analyze and visualize your data on a map. It's more than just a map. There are data management tools that support integration throughout your organization using your enterprise data management systems. What I'd like to do now is bring it all together. I want to take the elements of the LRS that Eric showed you and elements of schematic diagrams that Koye showed you, and I want to demonstrate for you one creative way to use them together inside of an interactive web application.
This is the demo for integrating schematic and geographic views of rail data with the Esri Roads and Highways solution. In this demonstration, I'm going to work with Chicago Transit rail data. I will be someone who needs to maintain the information for rail crossings, as well as speed, grade, and train director. I'm going to work in an application built specifically for me to visualize and maintain this data. So let's take a look at this app. Here you see three views of the same data: geographic at the top, then below it schematic, and straight line diagram. This is a custom application built using the ArcGIS API for JavaScript and the Esri Roads and Highways web services. The Roads and Highways web services are used to synchronize the geographic and schematic views. The red cross in each view represents the same relative location along the track. The straight line diagram views at the bottom show the attributes for speed, grade, and train director for any location along the track. This application is focused on just a single track, but it could be modified to allow someone to work on any track. The schematic view here in the middle was created from CAD data. Both the geographic and schematic data was loaded into Roads and Highways as separate data sets, but they were calibrated with the same measures. So let's first pan the schematic until we mark Division Street. Notice that while we are moving the schematic view, the geographic view changes to sync with it. When I click either of the red cross markers, the measure in the pop-ups are almost identical, the only difference being the accuracy of my mouse skills. But in reality, the measure values of these 2 points are in the same spot. Now let's pan over here to the right, which geographically is north, so that we can add a new intersection here at Gulf Road. Clicking on the track, here where the track crosses Gulf Road, gives me a pop-up with a link, Add a New Intersection Here. Clicking that launches the event editor and passes information about the click location to the app. You can see that information here in the panel. So let's set some attributes for this new intersection. The intersection type is road, where the track crosses the road. The intersection grade is at grade, not an overpass or an underpass. And the crossing name is Gulf, which is where it crosses at Gulf Road. Let's go ahead and save that. Now let's go back to the multi-view app, and we can pan slightly to see that the new Gulf Road intersection has been placed on the map, both in the geographic view and also in the schematic view. Now that the rail line is split at Gulf Road, we can modify the linear events south of or north of that intersection separately. So let's click the new Gulf Road intersection and select Add Linear Events here. The Gulf Road intersection starts at about 15.87 miles. So let's make a length, which is 1 mile north of that, and click Next. Now let's set some attributes for that 1 mile section of track. Let's make the grade 0.9, passenger speed 20 miles per hour, speed of other trains 50 miles per hour, and then the train director, we're going to assign that to Amtrak. Let's go ahead and save. Let's go back to the multi-view app and close the pop-up. Now as I move here in the straight line view, this section here, the 1 mile stretch north of Gulf Road shows the new information about grade, speed limits, and train director. In this demo, we saw how Esri Roads and Highways can be used to provide a synchronized view and also a synchronized editing and data maintenance experience on rail data in different display modes useful for rail operations, in this case, geographic, schematic, and straight line. Thank you.
That's awesome. That's a really neat example for using a transportation map, in this case, railroad maps, in different modes. Sometimes a geographic view is best, especially when you want to see how things relate to the rest of the world in a map that preserves accurate scale. And sometimes a schematic view is best when you're more interested in the relative position of different elements and connectivity between them. So to sum up, linear data is a central part of transportation infrastructure management, regardless of the mode. And managing that movement data both in real time and analyzing patterns over time and using techniques for managing your assets and vehicles requires a lot of linear data. Thanks to Eric, we got a nice overview of location referencing options, how linear referencing works, and how it can provide a more useful way to refer to vehicles and transportation infrastructure in a way that relates better to the rest of the transportation system and between systems. Next, Koye Brown introduced the ArcGIS Utility Network. And while we named it that, due to its usefulness in various utility implementations, it's also a reasonably natural fit for transportation use as well. So in that respect, it's becoming a bit misnamed, but that's okay. More important than the name is its capabilities and how it can help you improve the quality and completeness of the digital twin. In fact, while we showed a bunch of rail examples, I can share with you that work has begun for building a utility network data model specifically for railroads. While this isn't an attempt to create some type of industry standard, especially since many railroads have some uniqueness in how they run their operations and maintain their data, our intent to evolve better enabling technology leads us to believe that we can at least cover as many common denominators as we can. We've begun recruiting a focus group from amongst our rail user community, and not just freight rail, but we have help from other rail organizations as well. Class 1s and short lines, but also commuter rail, transit organizations, light rail, subways, even maritime ports, where rail infrastructure is an important part of a port as a multimodal facility. If you'd like more information on that, feel free to ping us and we can discuss your involvement. Next, solution engineer Koye Brown used utility network tools with rail data and showed you what it can do to model connectivity and flow in ways that mirror how trains work in the real world, building a platform for better spatial analysis, better map visualization. Then lastly, we brought it all together, showing one creative way to combine LRS utility networks and schematic mapping in a synchronized way. We really appreciate your time. We hope you learned a bit about work that we at Esri are up to for evolving the tools and techniques that you rely upon for managing our infrastructure and for making effective, profitable, and safe decisions. We've got time now for questions. We'd really like to hear what you think, what might not have been clear, perhaps what was missing, and most importantly, how we can better help you succeed with your use of ArcGIS. Thank you.